All right. Hello, my name is David Margolin, and I'm your host in today's Knowledge Exchange webcast, where we will discuss extreme weather with Professor Randall Cerveny. Did I get that right?
You did indeed.
Cerveny. Okay, close enough anyway, right? Professor Cerveny is a professor of geographical sciences at ASU, where he's taught since 1986. At ASU, he directs the meteorology program and was awarded the title of President's Professor in recognition of his contributions to undergraduate education. He's also a contributing editor for the magazine Weatherwise, which we just talked about offline for a second, and is the author of numerous journal articles, as well as two earlier books, Freaks of the Storm and Weather's Greatest Mysteries Solved. And most recently, and really why we're here today and the focus of today's discussion, Judging Extreme Weather. So with that, Dr. Cerveny, why don't I turn it over to you, and maybe we can start by you giving us a little bit of background about the WMO and their role in extreme weather, and also maybe talk about the motivation behind your new book.
Cool. Well, the book is all about a project that we started way back in 2005, actually 2006, as a way of figuring out officially what was the record weather that we experience. What is the hottest temperature the Earth has seen? What is the coldest temperature that we've recorded on the planet? What is the windiest wind measurement we've made? And all of those types of things. Individual countries like the United States have a group put together to determine weather extremes. So for the United States, it's called the U.S. National Climate Extremes Committee. And that is some experts, one from NOAA, one from the State Climatologist Board, and other people that get involved with that. They look at the evidence when a new record comes for the United States, and they determine whether it was measured properly, whether it was whether it's basically valid or not. Really good system. The UK has something like that. Australia has something like that. A number of different countries have different ways of verifying their extremes. But we didn't have that for the entire world, and that can be somewhat of a problem. Was talking to you just before we started the cast here that my interest in this all got going back in 2005 with Hurricane Katrina. Happened to hear a reporter say, and we all know that when there's a big event going on, there is a tendency to exaggerate, but this reporter said that Hurricane Katrina was the worst hurricane of all time. And it was bad. 2,000 people lost their life. It was nowhere near the worst hurricane to ever be experienced. The worst hurricane in the Western Hemisphere here was the 1900 Galveston hurricane, where upwards of 6,000 or more people were killed in that particular hurricane. And it doesn't hold a candle to the worst hurricane-like storm around the planet, a tropical cyclone. The worst tropical cyclone of all time occurred back in 1970 in what was then East Pakistan, when a system came through and killed nearly a third of a million people in one storm. It actually led to the overthrow of the government in East Pakistan and the formation of a new country, the country of Bangladesh. Very, very bizarre. So I asked the question, who keeps track of global records?
Right.
And I talked with some of my colleagues around the world and around the country, and we realized that there's nobody that back in 2006, nobody was keeping track of global extremes. So my friends and I got together and we wrote an article. We published it in what's called the Bulletin of the American Meteorological Society, a pretty well-respected journal for professional meteorologists. And we said, somebody needs to do this. Well, you got to be careful what you ask for, because after that article was published, I was contacted by a group that's called the World Meteorological Organization. They're part of the United Nations. They basically are the United Nations of weather services, that all the weather services from around the country, or from the world rather, get together and they determine the standards. How are temperatures going to be measured? How are winds going to be measured? All the different things that we have to have so that our records are comparable from one country to another. And they came to me and they said, this sounds like a really interesting idea. Why don't you come out to Europe and explain it to us? And so I did. And they said, you have a really good idea. Well, we're interested in you guys doing that for us as long as you run the project. And I said, okay, well, I suppose I could run the project for a while. Well, now we are into 2024, some nearly 2 decades later, and I'm still running the project. But it's been really, really cool. It's been a chance to put an official stamp on some records that a lot of people have interest in. What is the hottest temperature recorded on the planet? What is the coldest temperature on the planet? Strongest winds? All those kind of records are being evaluated by committees that I put together of international superstars in meteorology. We analyze the data and then determine whether it's a record or not. And some of these records, according to the press office in Geneva, Switzerland, for the World Meteorological Organization, some of these press releases that we have on weather extremes are now being seen by the entire planet. Our last announcement, which was involving some lightning extremes from last year, the head of the press agency at the World Meteorological Organization told me that it was a combined population of the world that saw this press release that was put out by the WMO of roughly 6 billion people. So the potential was there that almost everybody on the planet saw the announcement when it came out.
Yeah, it's amazing.
So yeah, so those kind of things, and that one was pretty impressive. That kind of extreme was an absolute new extreme to us. It was an extreme in lightning. We now have the technology to measure how long a lightning flash lasts and how far it can travel, one single lightning flash. It used to be the old textbook definition of what a lightning flash was that it was an electrical discharge that lasts less than a second. Well, we now know, using our new technology, that lightning discharges can last upwards of 17 seconds in extreme situations, and they can travel as much as 470 miles. That's the equivalent of traveling from New York to Columbus, Ohio, one single lightning flash. So those kind of records, when they come out, really excite people. And so we've gotten a lot of publicity about our world weather climate archive that we have of extremes.
That's really awesome. So let me see if I can. I'm going to show my U.S. bias here a little bit, if I can ask. But and in my background tends, I think I mentioned earlier, it tends to be in energy finance. So we focus a lot on, temperature extremes and storms, both winter and tropical. So in terms of those areas, and again, especially across, say, North America, did your research sort of confirm what you expected to find? And what were your expectations? And were any of the findings, provocative, really sort of out of left field?
Well, our probably our most accessed, the most exciting of our evaluations that we do was one that took place back in 2013. It actually started all the way in 2010. It's a very long story. It used to be that the world's hottest temperature recorded on the planet was in Libya, and it was measured in a suburb, what is now a suburb of Tripoli, and it was a temperature of 136 degrees Fahrenheit. That dates back to 1921, and it had been accepted by lots of climatologists since that particular time, but we had uncovered some new information. We had actually got the actual logbooks of the recorded observations from 1920 and 21. And we were able to look at those particular observations, and we noticed something weird in the observation that was associated with this world record temperature, and we noticed that it was mismarked, and that we went back a few days and we found out that what had happened at that particular station was that the forecaster there had been killed. There was at that particular time, Libya was under the control of Italy, and there had been an incursion onto that particular fort, and their normal weather observer had been killed, as well as the normal thermometer that they used to measure that temperature. So they had a substitute, and they had gotten an old, very strange dual alcohol mercury thermometer to replace it. Well, those are really hard to read. They aren't used anymore because of various problems with them. And we found out that now there's a pretty good chance that that observation was made in error. So I put together the way that we work this is when we come up with a new investigation, I scour the planet for the best of the best. I kind of feel like Nick Fury of the Avengers here. I get to put together the Avengers teams for meteorology. And so for this, I pulled out the best people around the world that work with temperature records. And we started looking at this thing and uncovering different facts about how this observation was made. And this was all started back in 2010. One of the people that I had as part of my team was a meteorologist from Libya. He was the one that had uncovered the raw observation sheets that we were looking at. Well, he was at that time in 2010 working for the Gaddafi government. Libya was under Gaddafi's rule. In 2010 and into 2011, the revolution started. Mm-hmm. And all of a sudden, he dropped off the map. We didn't hear from him for 9 months. I kept writing him emails and was not getting any kind of response. And I was thinking, uh-oh, what's happened? And then one day, out of the blue, I get an email from him. I'm alive. I've survived. What he had done is he and his family gotten into a car, and he had driven out of Tripoli as Tripoli was being invaded by the rebels. He had gotten a car and drove out of Tripoli. He said that there were gunshots over his head and over his family's head as he was doing this. He got out of the city and joined the rebels. And he then, as the country settled down, he got his old position back, but now with the new rebel government, and he's still there, by the way. You don't think of meteorology as being one where you get shot at.
Right, exactly.
He actually got shot at. So using him and other experts in the field, we really finally looked at this particular record. We discovered 5 different things that were wrong with it. And based off of that, my team of experts said that the strongest likelihood is that temperature was invalid. So we invalidated it. And we now have the world's record for the hottest temperature for the planet is 134 degrees, and it was recorded in Death Valley. So this is the kind of thing that we actually do. We look at the records, we make sure that it was the proper instruments, that the instruments were working in the proper way, they were calibrated, that the measurements were done with the right observations over the right terrain. We have lots of little criteria that the World Meteorological Organization sets up for how a measurement is supposed to be made. And we make sure that everything follows in line. If it does, it becomes verified, and we can say that it's a world record or a hemispheric record or a continental record. But if it's not, then we reject it.
Interesting. Okay, yeah, I didn't realize there was so much involved in that. So let me ask you in particular about, I feel like obviously I'm not a climate scientist, I'm a meteorologist. We talked about that a little bit. So, I'm always looking at the short range, but, occasionally looking a few months out and things like that. And certainly, sensitive whenever we make when I make seasonal forecasts, things like that, I'm sensitive to the climate change signals because it's I think in our industry it's almost impossible not to consider that, especially certain seasons, different regions. But not, I mean, I want to get to climate change in a second, but just in particular with, I would say, in the United States, temperatures and like winter storms. What has your research showed in terms of those phenomena? And in the context of, I feel like a lot, obviously a lot of us, we hear about the weather through the news and things like that. And it feels to me anyway, and I suspect others that what you hear is that extreme winter storms, extreme or temperatures on the extremes are increasing. At least it feels that way. I recall 2, 3 winters ago, we had a very bad cold event or significant cold event down in Texas, caused problems on the grid down there. You probably remember that. And almost instantly, you're hearing stuff about, well, yeah, that's because extreme weather's on the move. It's increasing. We're going to expect more of this. And that always, I struggle with this just with my limited understanding of things because I'm like, okay, I understand with climate change, we're getting warmer and there's some very definitive things and this and that. But, is there really strong statistics there and other research that you may have dug up that shows, yes, we should expect, more or less winter storms in the winter? And same thing with temperatures. If you're in Minneapolis or you're in Chicago or New Jersey or Arizona, should you expect more extremes both in terms of the cold and the hot? Is that really a thing? Or is that something that just I'm perceiving, based on things that I'm hearing from the news media and such? So there was a lot there, but go ahead.
Yeah,
Go ahead.
yeah, yeah. Well, one thing is we work with global extremes. We work with extremes for the globe, for extremes for the continents, and for the hemispheres. We leave the individual countries extremes like winter storms and such to individual countries. And so I don't think even, for example, that the U.S. Extremes Committee looks at individual winter storms for any kind of records in terms of temperature or that type of work. But here's what when I get that kind of question, here's the kind of thing that I can tell you. Even though when I started this thing, I figured that we would be working with an evaluation of an extreme maybe once every couple years or so. I currently have 3 evaluations ongoing right now. We are having many more extreme evaluations than I had anticipated. Of the majority of those kind of observations, most of them are going to be involving temperature and warmest temperature. We just had an announcement a couple years ago of the highest temperature recorded in Europe, and that was in the island of Sicily, off the coast of Italy, actually part of Italy, but they set an all-time record of 48.8 degrees Celsius, almost 119 degrees Fahrenheit there. So we are seeing that kind of thing. Even for you or your listeners here, think about this. When you listen to the evening news and you hear that there's been a record set, I will probably guarantee you that that record will be more than likely a hot temperature record rather than a cold temperature record. Here in Phoenix, for example, we every year I've been setting all-time record high temperatures for individual days during the summer. The last time that we set a record low in the Phoenix area was around 25 years ago. So, I mean, you can look at the statistics, and yes, the climate scientists will tell you that the world is warming and that we are basically taking our distributions of temperature and we're shifting them to the right, so that what was normal now is going to become cooler, because our medium of the whole temperature curve is going to get shifted off to the warmer temperatures. And that's going to be seen in extremes, that we're going to see more extreme high temperatures, not so many extreme low temperatures. And in terms of the globe and the work that we're doing with the WMO, we found that that's the actual case, that we are seeing many more extremes associated with hot temperature. Currently, for example, Death Valley hasn't quite matched its record of 134, but in the last 5 years, it's hit 130 twice. And we're currently evaluating those observations. And one of the things, again, we want to make sure that the numbers are right. I hear a lot of critics saying, well, you fudged the data or whatever. That's my job, is to make sure that the observations were done correctly. For new high temperature records, we actually have the sensor from that particular location, the temperature sensor from that particular station, dismantled, a replacement put in. We take the one that was measuring the extreme to an independent testing lab, and we have it calibrated to make sure that when it was saying that there was a temperature of 130 degrees Fahrenheit, it actually was recording 130 degrees Fahrenheit.
Wow.
They put it into a testing facility that is kept at that temperature, for example, and we monitor how close does the actual sensor measure what is known to be a specific temperature. And we can calibrate it and make sure that it was working properly. If it wasn't calibrated properly, then we can say, no, that observation is invalid, and we're not going to pay attention to it.
Makes sense. So I want to clarify one or two things you said, just because I think they're really important. So going back to what you were saying about the temperature distribution, what you found is, the temperature distribution for majority of locations is shifting. It's shifting warmer, higher. But it's not clear to you, or your research hasn't shown, that the distribution is necessarily increasing or decreasing for that matter either. It's just that it shifted upward. Is that a correct way of putting it?
Yeah, although what we're finding is, and this is not my research, but this is other climate scientists' research, is that in particular, the morning temperatures are much higher than they have been in the past. The afternoon temperatures are increasing, but not at the rate, so that the diurnal temperature range, the difference between our low temperature and our high temperature, is actually getting smaller, because our smaller temperatures, or our minimum temperature, are getting warmer. So I've been asked, we've hit here in Phoenix, Arizona, our all-time high record recorded is 122 degrees. And I've been asked, are we going to exceed that? And I say, probably before we exceed 122 degrees as a high temperature, what we will see is that our minimum temperatures will not get below 100 degrees. Right now, the highest minimum temperature that we've ever recorded here in Phoenix, Arizona is 96. So what we are seeing in particular in this new age that we are entered into is that our minimum temperatures are getting much warmer. Our high temperatures are still increasing, but our minimum temperatures are getting much warmer.
Interesting. So, okay, so the diurnal, so this is a distinction. The diurnal cycle is maybe decreasing a little bit.
Exactly.
Is it fair to extrapolate that to like annual extremes too? And like, to give an example, like let's say we're talking about Chicago, and let's say we define extremes as the average number of days Chicago in a year that Chicago gets below zero, and the average number of days Chicago gets above 100 or 95 or something like that. Can you extrapolate the diurnal cycle to that, to say, well, since we know that the lows are going up more rapidly and the highs are going up a little bit, that actually, if you're looking at it in the context of extremes, and that how I defined it there, that like a lot of places may also be seeing a little bit of a shrinking of those kinds of extremes?
Yeah, again, that's not research that I have done, but yes, there are climate scientists that have looked at different cities and different regions around the world and found exactly that. One of the things that we have to worry about, though, when we're looking at that kind of thing, is that there are local effects that are going to impact the temperatures of a given area as well. So that when we are looking at Phoenix or we're looking at Chicago, you don't want to look at necessarily the center of the city, because you've got the urban heat island effect, which is also an extra influence on the temperature record. When we're looking at extremes, very often what we will be doing is we'll be looking at cities that are just outside the main area and comparing their records with the interior city to see if they are moving in the same direction, because the interior city's got that extra heat load that is also associated with things like concrete and asphalt absorbing heat and making the city warmer, the urban heat island effect. But we can, as climate scientists, there are many brilliant people around. Again, I have the fun of putting those brilliant people all together. I'm not one of them, but I put the brilliant people together. But we have lots of brilliant people that are able to distangle the urban heat island effect from the overall temperature records. And it's a very elaborate statistical process, but it can be done.
Good. So I want to pick your brain too, if I can, again, about something else you said that really struck me about mid-latitude storm systems. Because again, this is something I think a lot of us, we hear on the news all the time, or it feels that way. I don't want to use my words carefully, but like, when there's a major storm, California recently, right, in the last couple of years has seen a significant number of storms and whatnot. I mentioned the extreme weather that we had in Texas a couple years ago, or things like that. And but so what, if I understand what you're saying correctly, we don't really, there hasn't been really an extensive study in terms of looking at, like, again, non-tropical but more mid-latitude extratropical storm systems, and if we are seeing either an increase in frequency of these types of storms. And I know it can be very regional too. Again, if you're looking at the Western United States, you're looking at certain types of storm patterns. If you're looking at the Northeast, nor'easters. If you're looking at Arizona, might be something else. But is there not like a really good database or a study that's looked at how those are changing, or potentially how, in the last 30, 50 years, how those have evolved in terms of frequency, intensity, and things like that?
Yeah, there have been. That's not what I do.
Okay.
I'm involving with extreme the extremes of the extremes is what I'm looking at.
Okay.
So when we're looking at storms, we are looking at extremes in tornadoes, for example. We have records that give us the absolute extreme that a tornado can get. The winds, the maximum estimated winds based off of Doppler radar for a tornado have been measured at 302 miles an hour. We know that the maximum width as recorded by Doppler radar for a tornado is 2.5 miles wide, one tornado. So what we're the largest hailstone that has fallen has been a hailstone that fell in Bangladesh that weighed 2.2 pounds. So what we're looking at, what we're trying to classify, are the absolute extremes of the extremes. How big can our weather get? We're going to be announcing in just a few months a big evaluation that we had over the last year about a tropical cyclone. You might remember at this time, around this time last year, it was a big tropical cyclone that was called Freddie that started off the coast of Australia, and it traveled all the way to Africa. And it took a month for that to travel from Australia to Africa, and it stayed together as a tropical cyclone. So people started saying, is that the longest lasting tropical cyclone that we have on record? Our current tropical cyclone, that is the longest lived cyclone, was a tropical cyclone that occurred back in, I got to check the exact number here. Hold on. I think it was, I don't want to say something and then and then have it not be the case. Hold on. Oh, come on.
We're going to fact check you on this.
Yeah, exactly. Yeah, 94. I was right. Okay, I could have said that. It was a tropical cyclone that occurred in the Pacific that was called John. Actually, it started out as Hurricane John. It crossed the international date line, became Typhoon John, and then died out. And it lasted 30 days. So the question was, is this one that we just had, Freddie, last year, as long lasting or longer lasting than John was? So in order to do that, we have to get some pretty high powered people that know everything there is to know about tropical cyclones onto a committee. And we got all the evidence for tropical cyclone Freddie. And actually, because this record with John had been grandfathered into the archive, it had come from an older record that had never been fact checked. We decided, okay, we're also going to fact check Tropical Cyclone John and make sure that its numbers were actually right. So over the last year, we have been doing that. And I can't tell you what we found because it's going to be announced in the next month or so. But we will have a major announcement about tropical cyclone duration that will be announced out of Geneva with the World Meteorological Organization.
Well, it's speaking of tropical cyclones, maybe that's a good segue. Is there anything else in terms of tropical cyclones? Again, it could be specific to Atlantic, but global too, in terms of your findings. Because again, it seems like that's an area too where you mentioned Katrina at the beginning of this, and I remember right after Katrina, it was like, okay, we're going to this new paradigm. It's going to be, we're going to see that kind of thing, or at least it seemed like there was sensationalism on that regards. And then the next season, we had like a relatively low season, as I recall, and and it was much more variable after that. But yeah, what is your research shown in terms of extremes related to tropical cyclones, other than the duration tease that you just gave us?
Well, one of the things that we found is, and a lot of people, particularly the people that are on the East Coast, don't really realize, is that there is a very big hurricane season that takes place off the west coast of Mexico. And an investigation that we had, again, got to make sure that I get the actual number right here. Hold on. An investigation that we had back in 2016 was that there was a hurricane that was off the west coast of Mexico that hardly got any mention because it didn't really impact a whole lot of people. It occurred off the West Mexican coast. It spun around for a while and then it made landfall. But when it was out in the oceans just to the west of Mexico, it intensified. It cascaded into a cyclonic bomb and really, really deepened in its pressure. And we were thinking, the people at the U.S. National Hurricane Center contacted me, and we said, well, I wonder if that might possibly be the most intense hurricane that we have seen in the Western Hemisphere. And so we put together a committee. We investigated. It was Hurricane Patricia, and it actually beat out the previous holder of that record, which was Wilma, which was also during the Katrina year of 2005. But the biggest, the most intense hurricane that we have had on record for the Western Hemisphere is Hurricane Patricia, which took place in 2015. And as I say, not very many people know it because it wasn't a killer. It actually did kill 2 people, but it was very, very limited on its impact along the Mexican coast. It was just kind of spinning its way out off the coast and then dropped like a ton to an all-time low intensity, created some massive, massive winds.
Yeah, you're right. It's fascinating. I follow the East Pac storms somewhat, but as you mentioned, a lot of them thankfully become fish storms, as we like to call them,
Right, right.
impacting shipping lanes and things like that. But thankfully, normally kind of going out to sea. So let me.
So
Yeah, go ahead.
Yeah. So as I say, one of the cool things here is that we're getting attention drawn to places and to phenomena that we hadn't known. I was mentioning earlier that lightning record that we have. When we announce something like that, the new longest distance that a lightning flash can travel, and by the way, that one was, as I mentioned, 477 miles. It was all the way from the coast of Mississippi to the southern part of Texas, one lightning flash. But when we announce those kind of records, what is also really nice is that we can reemphasize the safety instructions that, okay, yeah, one of the things to realize about lightning is that it can travel a very long distance. So when there is a lightning storm in your area, you should go inside, that you shouldn't, and I like the idea of being able to tailor our extremes when we find the extreme of an extreme, the worst tropical cyclone or the longest duration tropical cyclone. We can also couple that with important weather information about what people should do about those kind of disasters, potential disasters.
Yeah, exactly. Let me see. I have just a couple more questions. we didn't touch on snow too much. I don't know. Did you in your studies have you looked at snowfall and anything interesting that came out of that, either U.S. or globally?
Ah, that's the touchy one. That is the one variable that we do not address in the World Meteorological Organization, and that's because it is such a hard thing to measure. And you think snowfall shouldn't be that tough, but actually one of the most contentious debates in the United States, and the United States does actually monitor snowfall records, that they took a record of snowfall. It was something, I believe, on the order of 71 inches that occurred in New York. And they took that record away because the observer had been measuring the snowfall too frequently. And you say to yourself, well, wait a minute, how could measuring it too frequently lead to an invalidation? Well, when snow falls, one of the things about it is it compresses. And if you measure the snow too frequently, you're not getting the compressed measurements. So the World Meteorological Organization, the National Weather Service, specify, and when you're taking snow measurements, is that you should really only take snow measurements once or maybe twice a day. This particular observer took 6 measurements in a series of a couple hours and then added them all together. And that doesn't give you a record. Well, unfortunately, those requirements of taking limited snowfall measurements over a course of a time haven't percolated around the world as much as I would like. And so I have been really cautious about looking at any kind of snowfall records. I'm hoping that eventually enough of the world is going to know that that is the key. You have to take measurements in a limited time period, and you have to measure them over an open area with hopefully a snowboard and all the different things that are associated with snow measurements. But up to right now, we don't have that kind of ability. So I don't accept snowfall records into the archive at this time, but maybe in the future we might. And that's one of the cool things, is that this is a project that I hope will far outlive me, that we're going to keep continuing monitoring extreme weather around the world and updating that as well. I've even got a few astronomers that have asked me whether we could build a extreme weather site for other planets. We now have enough weather stations on something like Mars. Should we put together a extreme site for extreme weather on Mars? What is the hottest temperature that we've recorded on the planet? What is the coldest temperature? So far, we haven't done that because we're still in talks, but maybe someday in the future, we might be able to do something like that.
Looking for Elon Musk's job posting, right?
Yeah, exactly.
No, that's great. And I guess my final line of questions, I can't avoid this. What, in terms of climate change and extreme weather, what would what were your, I don't know, the most important takeaways, would you say, in terms of what you want readers to understand about the linkage there again between what you're seeing in extreme weather and what you're seeing with climate change?
Well, the key is that in order to have valid statements about climate change, we need to have a very good assurity that the current temperature measurements are done correctly, or the current weather measurements, whatever they might be, whether it's pressure, wind, tornadoes, hurricanes, everything in addition with temperature. We need to make sure that those measurements are done correctly. So the main purpose of the World Meteorological Organization's archive of extreme weather has been to validate the technologies, to validate the observations, to make sure that every T is crossed and every I is dotted, so that when we talk about climate change, we have a good solid baseline that everybody accepts as what we're going to be measuring from. And I use the example in the book that, when you're looking to find out whether you gained weight, what you have to do is, of course, you're going to take your measurement, but then you're comparing your weight to what you had sometime in the past when you accepted that particular weight. Well, what we need to do is to make sure that the temperatures and all the other weather variables that we're measuring right now are the accepted values. And then we can say, oh, we're seeing warmer temperatures than that, then we know that we are changing our climate. So the purpose of the project was to provide a baseline, a firm, solid, verifiable baseline that we're measuring everything correctly. And what I've over the last 20 years have learned is that we have some really, truly brilliant scientists around the world. And we've actually learned new things about our weather from this particular project, that by measuring our extremes and validating the process, we have a better understanding of weather.
Yeah, absolutely. And it seems in some respects, I feel like with extreme weather, it's one of those that seems like it should be much more well understood and easy to access this information. But when you start digging into it and talking to experts like yourself, you realize the complexities of this. And and like you said, with even extremes, the measurements, questioning the measurements and such like this of global records and such. So it sounds like you've made a huge kind of progress in terms of where we are now, but even more research to be done on some of these topics going forward. So, well, we could probably be here all day, but this was great. I appreciate you joining us today, taking some time out. I definitely encourage all of our readers or watchers to check out your book, Judging Extreme Weather. And I hope so much we can maybe have you back again to talk about some other areas of climate and weather.
I appreciate this. And one of the things to know about the book is I'm not the normal kind of scientist, because I like to have fun with weather as well. So one of the weird things that I do with this particular book, it's not a normal textbook by any means, is between the chapters, each chapter involves how we measure a different kind of variable: temperature, pressure, wind, hail, tornadoes, lightning, whatever. But in between each chapter, I give some odd, what I call freaks of the storm, unusual stories about that particular variable. So when I'm talking about tornadoes, I talk about a personal story that was told to me by Waylon Jennings. He was in his car and it was lifted up and spun by a tornado and then set back down on the ground. Those kind of fun stories I'm going to put in the book as well. So I'm hoping it's not only going to be informative, but it's going to be entertaining as well.
Well, definitely, and I'm glad you Waylon Jennings. So that was an interesting thing. I'm guessing a lot of our users are going to have to Google that one, but I definitely encourage them to do it and listen to some of his music because it's great.
There we go.
All right, well, thank you again. Appreciate you joining us here today.
My pleasure. Thanks for having me.
Bye bye.